So this talk and this morning are a little bit more taking back and into application sections. I think we had a great day yesterday. We had a whole lot that we learned and where we're going with low pass sequencing, and some of this is thinking about what we got for resources, what we maybe could try to get for resources going down the road that now close with, and then a really successful implementation of everything we've been talking about over the years with so I'm going to speak a little bit. I know your program says GPE. I think for the title, I teased Warren that I didn't hear back. Didn't get enough pressure from our organizer to get a better title than that. Sorry about that. So I came up with something sufficiently long to try to talk about. And anyway, I just want to emphasize a little bit more how we can use our Germplasm Evaluation Program in trying to help with the overall genetic evaluation system in the country. And what we can do with that. Mark hinted at this a little bit yesterday in discussions about using it to help with some of the parameterizations of the new modeling that he spoke about. This is a little more traditional than that, not a lot necessarily directly with genomics, but taking our systems and maybe trying to help with multibreed evaluation and get things a little bit better, which we've been trying to do as much as we can, and then some on environmental adaptation, where we're looking at our G-value study that we've been doing over the last few years. So I don't need to spend much time here. You guys have seen this. If you've seen a germplasm evaluation talk before, 18 breeds crossed together, make sure that we can get a giant diallele type of mating going as much as we can. Produce purebreds and crossbreds from that, sample the industry bulls, work with all the breed associations. I think you guys have heard us talk about this before, and collect as much data as we possibly can on the progeny and on the cows as maternal effects too. And usually the objectives that we've been always stating here, and these are the things we try to do in-house as much as we can. Breed differences are big, and crossbreed EPD, adjustment factors, and supplement our genomics program as much as we possibly can. It's a primary resource. Get genetic parameters, breed-specific heterosis, which, if you saw the poster last night that Bailey was speaking at, that's what that was on. Novel traits and contributing to decision support systems. But if you want to think about where we can do things that are a little more unconventional, these are research questions deep down, and of course they can impact the industry, but they're also what can we do to make sure that we can utilize this resource to make overall genetic prediction better. Just a little background. So this goes into trying to look at multi-breed evaluation, and I've talked a little bit about our crossbreed EPD system that we've had for years since the early 90s, with some work with Dave Notter and Larry Cundiff developing this originally. And basically, make sure I get this to work here. There you go. So basically, we figure out a breed difference by adjusting our solutions from a mixed model at Amino Research Center and adjusting it for the EPDs that we sampled relative to what the mean of the EPDs are. So this is a weighted mean average of the EPDs for the bulls we sampled. This is the EPD of the current breed average, adjusting for that sampling, and then adjusting our solution that we're getting out from mixed model by a scaling factor, which is based on a regression of how well the EPDs actually reflect the phenotypes that we're seeing at the Amino Research Center. Okay, so that gets a breed solution, and then that simply calculates the crossbreed EPD adjustment factors by subtracting that from Angus. Angus is used as a base breed in that, as most of you are aware. And that's also deviated then from the average EPD for the breed in question and the average EPD of Angus. That gets a factor, so that if you add that factor to those EPDs, you can compare them on an equitable scale to Angus. You can subtract those factors if you want to compare to another breed. And I don't think this is new to anybody, but it's just a primer to look at what I'm trying to do with multi-breed and where we go. Some of this I spoke about at a BIF a couple of years ago, and some of it's new. But this is multi-breed evaluation. This is an old slide, so I don't have my count right. Ryan, let me know if 17 is wrong. If you're counting on your fingers here. But I know there's a lot of breed association partners in the IGS system right now. Records, the court gets records from and produces EPDs for crossbred and composite populations that are derived from all of those breeds. And trying to estimate this differences across breeds is one of the primary goals of that evaluation. So question we always get, and I know that everyone in IGS gets as well, is why are there still crossbreed EPD adjustment factors if we have a multi-breed evaluation to compare animals across breed, right? And simple question is that part of this is just that the factors are not quite the same in what we get as what we see in multi-breed right now, and we want to see if we can do better. So one objective of this, what we have, is to try to make sure we can match that multi-breed a little bit better and try to give people one solution instead of two. So just thinking about really quickly, what is there in field data versus research data and what's available in these types of populations. So there's a whole lot more data in our field data in the IGS system, for instance, but it's limited by how the comparisons that you're worried about in terms of breeds are actually connected to each other and actually the comparisons being made within contemporary groups. Not something I have to tell this group necessarily. GP is much smaller than that overall, with the number of animals dedicated to it per year, but it's designed to make those comparisons within the breed or within these groups directly because the animals are running together all the time. Still, there's a lot about field data to offer, and it certainly helps estimate differences. So how do we get things on the same page? And the question really is, how close is the multi-breed now to the adjustment factors we get right now? So what I did for that is try to fit it, the IGS breeds as sort of a super breed in our crossbreed EPD program. So basically combine breeds into one breed being estimated in the crossbreed EPD, and looked at the deviations of that super breed solution from the breeds if they were fit as individual breeds instead. So how close are we relative to that average super breed solution, and produce a single solution for that. So I did this two different ways where just the largest four breeds in IGS were used. That would be Gelby, Simmental, Red Angus, and Limousin. And then where all the IGS breeds that we have in GPE, which totals 9, were compared in a super breed at the same time and produced that single adjustment factor both ways. And then we can look at the standard error of breed differences from us. That's the main source of error in this, because a lot of the other sources of error, averages of EPD, so forth, get pretty small. I realize I am making an assumption there, but I think that standard error of the breed difference is probably the largest contributor to the error in this. So that's what I reported for this, and summarize that for growth traits right now. So this is what I had so far on that. This is from a couple cycles ago, but it's still, I would say, pretty current for the most part. I did the same thing. So these are the base factors of those breeds. If they're fit as individual breeds, this is the adjustment factor for that year that I calculated, right? This is the adjustment factor for the combining into a super breed of the 4 breeds or all, right? And then this is just a look, if we're fitting the 4 breeds as a super breed or all 9 breeds as a super breed, what is the deviation of their own solution from the combined super breed adjustment factor, right? And that's the standard error in quotes of the birth weight solutions from the Animal Research Center. And you can see, for the most part, I'd say if I'm looking at standard errors on this, on birth weight, we're probably fine both ways. that these could be combined, and we're probably getting pretty much the same answer here, right? If I go on to some of the other traits, it's a little tougher. I'd say we're doing pretty well for the most part within expectation, maybe just a little outside on some on 4 breeds on the 4 breeds fitted as a combined adjustment factor. But there's a few outliers, a little bit more if you look at the smaller breeds in that system right now for the adjustment factor on medium. And yearling weight, I would say see that even a little bit more so, where there's some deviations. We're well within error on the 4. We've got some pretty decent size outliers here when we look at the other breeds altogether, the extra ones. So maternal milk won't spend much time on them, very similar. My take home from this is I think we're doing a really good job, and connections are happening really, really well with the 4 larger breeds. I don't think that's a surprise. There is a connecting breed for all of those within that genetic evaluation system. I think everybody knows that, right, with Angus and how those breeds are coming together right now. And there's probably a little bit less data in these smaller breeds that are getting that clear tie and connection in most of these cases right now. Okay. So, the next step is what to do about that next. So I took the same data set and tried to look at working with some covariates that are fitted that Ryan sent me here, unfortunately about a year ago now. So I finally got to it here under pressure in the last few weeks. That's the way things work. But Ryan sent me covariates for the breed solutions they fit. And this is, take a step back here. This is a fundamental difference from the way we're analyzing the data relative to the way the data is being analyzed in the IGS system right now. When we take those breeds and the sires, we assume the breeds are representative of their breed type that we're looking at. So what I mean by that is we sampled so many Simmental bulls, for instance, right? And we treat them in our model as a purebred, this is a Simmental, right? What color are Simmentals, right? Are they purebred Simmentals? Where are they at right now? They have a lot of other breeding into them, right? Potentially, not all of them, they're full bloods, but the samples that we took mostly are partially Angus. And even more so today in terms of registration, a lot of those animals are composites, right? In terms of what's being registered. And so we are fitting them as sort of a base. Here's the Simmental. What's going on in the group solutions and IGS right now, Ryan, stop me if I'm wrong, but is they're being fit as covariates for the breed percentage that they are within that program. So they're actually estimating something slightly different than we are. Or they're estimating the purebred breed base effect. Well, we're estimating as though those are our founders in our system and they are purebred representation, right? And the objectives are a little different for how things are set up originally. We want to see what the current differences are between breeds originally. That's a GP objective. But in order to supplement this model, we need to be thinking, how do we maybe model and do these covariates from IGS a little bit better? So that's why I got those from Ryan. And I tried, in this preliminary look at it, using those covariates in our model instead of our group solutions to get percentages of several different breeds. And so the base breeds that sires that we sampled, I fit those covariates for those sires instead of fitting them as groups on their own. And then there's also an Angus within IGS and Angus that we have sampled. And so I wanted to compare that covariate Angus to the Angus that we've sampled for our groups overall and how much different they are. And for this case, the EPD adjustment that I showed here a little bit earlier for the crossbreed system isn't quite as clear because the EPDs are on an individual animal basis and not on those covariate group solutions. So I haven't done that yet. I modeled this right now just as the differences between the group solutions that we produce and the covariate solutions that come from fitting those two breeds. Hopefully that all makes sense. So these are what we're looking at right now. So the columns on the left for birth weight are the purebred solutions right now that we derive from our own. And for birth weight, these are the covariate solutions that we would get from fitting those covariates instead for those breeds effects. Okay, not bad, right? I'd say there's a little bit of noise, but definitely within these standard errors for this. I included Hereford in there so that I can just say I'm doing the right thing, because Hereford really didn't make a very big contribution to those IGS, and I want to make sure my solution stays the same relative to Angus. It does. So let's just put a benchmark in there. And then the others, I expected them, if anything, to deviate a little further in their difference from Angus than what they did before, because they're being allowed to be expressed relative to the Angus proportion most of them have in there. Does that make sense? So this looks pretty decent for birth weight. And I would say in this case, you know, Angus is a little bit higher than if you deviate it from the Angus word deriving from the purebred Angus we sampled, but it's pretty close, definitely within error. If I look at yearling weight, things get a little tougher. And I'm not, this is a place where we need to figure out and talk a little bit more, of course. But covariate still, Hereford, my benchmark, still doing what I expect here. For the most part, a lot of these actually end up rising rather than deviating further. And the Angus solution from those covariates is quite a bit lower than the Angus from what we would predict from what we sampled. I don't have a sure reason on this. My supposition is that part of this is because the Angus that influenced these animals was probably an older sample than the Angus that we have trying to update within our system right now. Okay, so genetic trend is not in maybe all of these quite the same way. The other thing about this is it probably also, it's probably not the same for each of the breeds that participate in terms of the age of when that Angus was brought into the breed. What I would expect also then is if we have composite sampled, which we don't right now within our GPE program, that has much more recent Angus sampling in those now. I would expect this to go up a whole lot more if we were evaluating those Angus composites for each of these breeds. Okay. Hopefully that makes sense. What we need to do going on from here is think about how these come together. Since I got these, and like I said, I got these about a year ago, things have changed with how the groups are being fitted into, the covariates are being fitted into the system. And I want to see if we get even closer. The good thing here is even though these do change a bit, I think they bring us actually closer, if I'm thinking about it right, for what the breed solutions would be from our system, and where we might still be seeing a little variation in the crossbreed EPD system. So I think if we're doing some composite of these covariates, we can get our answers closer and come down to where we have a single factor being produced for IGS within the system, and that's the ultimate goal here, right? So I'll be continuing to stay on the line with Ryan here and trying to get this the best. But this is just a good demonstration, I think. What can we do to help supplement systems? And, you know, there might be a place, we already help with the carcass data right now in IGS with our solution. This might be a place where maybe we have information that helps with some of those minor breeds a little bit more and brings them into a focus because it's the information we have too. So this is a place where GP is not necessarily designed for, but it's a place where I think we can utilize the resource that this is. So that's kind of a take-home message from this. Like I said, in general factors well within error. I think even with the co-breeds or the earlier study, we can do a good job of bringing in those 4 breeds as a super breed. I think we're moving toward that point next, probably. Those of you that are here for breed representation, you saw us in an email out asking for these again. So we'll try to do that and see what we can produce this year for the next iteration. And then reflecting groups fit in the multibreed evaluation rather than using purebred assumption that we have might improve the concordance quite a bit. So that's my take home there. We'll continue to collaborate. I already said that, and we want to make this better. And we need to think about what the best way is to go forward. So my second part of my talk here is on the beef grant challenge. And this is a project we've had going on for the last 5 or 6 years, where we were sending stocker cattle out of our GPE system to different locations in the country to look at how different management systems may or may not cause these breed solutions we get to re-rank. Okay. So a traditional G/E study, but everybody knows that traditional G/E studies aren't done too much anymore, and there's a good reason why. So they're tough and expensive. And if I learned anything out of this program, it's that, right? This is not easy to get done, but this is a good stab to try to get things going. And so this is what we started to do. These are the research locations involved. I'll talk a little bit more about each of these right now, but cattle were essentially sent up into Montana, Colorado, on prairie on western Oklahoma, or in wheat pasture in central Oklahoma, and then or they were sent and kept in our system as captives in the Research Center in Nebraska. Our other partner out here in Grand Forks, North Dakota, was the Human Nutrition Lab, and long term they're going to be looking at the fatty acid profile from each of these, and still are analyzing that data right now. So mainly use a collaborative stocking program to evaluate genotypes in multiple environmental management systems to get an idea of G by E by M interactions. E and M are actually confounded here because the environment and management are really for a location. So it's really a G by location effect overall interaction. And basically, we wanted to make sure we have breeds of sire families evaluated and utilize females from our GP native trimmers to get there. And this is the crossing strategy we used to produce the progeny for that. We have these GP females, as you know, several different breeds going into that, crossed to these 4 breeds, largest, most prominent breeds in the US, right, in terms of numbers, and we used a Brahman composite. Generally tried to get that to be Brangus. We had to use Beefmaster a few years. I don't show the Beefmaster solutions here because we didn't use it too much. We're still trying to refine that a little bit, but this is our model. And essentially, we took progeny out of that and made sure that we tried to represent sires in each location. We tried to balance that as well as we could. And of course, if we balance the sires, we tried to make sure the number of representatives in each breed each year was the same in each location as well. And it was done in 2 different phases. There was a spring group. This is the larger group, the one that is a little more powerful, where they were sent on Miles City, Montana, the livestock and range research laboratory there, and the grazing lab research laboratory in El Reno, Oklahoma, where the wheat pasture was, about 120 a year. We did this for 3 years for every group, every location, and 4 years for outright people. Couldn't send to Miles City the last year because of drought conditions up there. And then we sent 40 dead from our fall herd at the time to locations in Colorado, Prairie, and in Woodward, Oklahoma, and got 40 of them. And as I said, we tried to make sure things stayed as balanced as possible. We parentage tested these animals by getting blood samples on them, and they during their pre-breeding vaccinations, and used the same number of progeny from each sire and dam as much as we could get this balanced. This is just the environments and the standard of care and management in each of those locations. with Clay Center. We had a receiving ration for their backgrounding phase, which was pretty short, usually just a couple months is all. And then they went on full feed relatively quickly, a typical cat feed system for the Nebraska area. In Miles City, Montana, they went on the winter range. As you can imagine, that's not a place where they would grow very fast or a lot. And then in El Reno, Oklahoma, they were on wheat grazing, and the fall herd went into these other locations where they were on short grass or mixed grass prairie for summer stocking levels. And that's a common program, of course, that a lot of people use for fall grazing overall. And so the question is, are the top performing breeds everywhere? Overall, measured weights as much as we can, try to get a good monthly weight grade. We didn't implant these animals. We wanted to take the implants out of the equation on this. That also helped our grade in each location, I'm sure, a little bit. And we tried to keep the rations for the finishing part of this phase as close to energy content as we possibly could. Obviously, that's not completely possible, but we tried to make sure that they were staying representative of their location, i.e. steam flaking, maybe down south, maybe more corn up north, that sort of thing. And targeted about 1,350 pounds finish at each place so that we finished at approximately a weight constant endpoint for the average. And then collected a lot of harvest trays at the same time for that. Just some additional measures. We were looking at rumen fluid. This is still being analyzed too to see about rumen metagenome differences from going on different rations. These siblings that started together, did they diverge when they went into some of these other rations, these other backgrounding regimes, and then come back together. Several other things I mentioned, helpfulness, food safety protocols were in this a little bit. So all of that. This was the means for each location for the spring groups that got sent out, and you'll see a decent job. Some of these stayed pretty consistent on our growth rates. Some of them did not. Winter range in Montana is pretty tough. This is kilograms per day, and they don't gain a lot when they're there. Without getting supplemented. Some years, the first year, I think they were only able to do that for about 2 months before snow cover, and then they had to start back feeding themselves, right? And they gained almost nothing that year, a lot of negative weights actually. Other years that went a little bit better, so we had a positive average overall, but it's tough. We actually, on our background and receiving rations, don't do as well as wheat pasture, and wheat pasture was where they stayed on the longest in all these background systems. And not surprising, that's a high quality forage source for a reason. Weights, again, we tried to target those pretty close. We didn't do too badly with that. Maybe a little variation there, but not awful. This is the spring or the fall herds that got sent out in spring to each of the locations. A little bit of difference. We actually did better on the short grass prairie often in the summer than we did on the mixed grass prairie, which surprised me a little bit. No data from the feedlot phase yet on woodwork. We're still waiting on that, but this is where we ended up on most of those. For locations on some of the carcass composition, I think, as I said, grade was pretty decent here. This is a middle choice, I think, at a 6, if I remember right, or this ended up at. Not bad. And a little bit fatter on our system going from that receiving ration to backgrounding. That showed in both yield grade and in fat. Rib area may be a little smaller as a result of that, relative to Reno, but not necessarily a lot. And that's tenderness, slice your force. Don't try to convert it to your warmer Nebraska necessarily. It's different, but this is trying to simulate eating. What we've been doing at the Meat Research Center for a long time now. Lower numbers are better and correspond a little bit with marbling maybe, but they're definitely a little smaller in our system than the other places. This is a look at it then on the fall herd, and interestingly, we aren't consistent with tenderness between those two in our own location. Our other numbers are pretty similar, and I don't see as much spread here. So this is, I don't want to spend a lot of time on these because this is very preliminary right now. We just got these done and we've got some error checking still to do, make sure this is, but this is where we might look at those interactions and where they are. In each of these slides I've got right now, you pretty much got Hereford, Brangus, Charolais, and Simmental together, in each location at the bottom axis, right? And look at those, and basically these are deviations from each place relative to Angus. So these are differences from Angus for each one. So interaction contrast, right? If they go up above the line on one and down below the line on the other, it probably means there might be something there, right? Within whatever the error is. And I purposely didn't show error here, but because I'm still calculating it correctly, actually. But it definitely factors in here. Probably decent size in some of this. Do see some interaction potential on that early backgrounding, which is probably the place I expected the most, and some places where we had some real advantages relative to Angus in that wheat pasture on that growing. Not a surprise given the average area gains we were seeing there, I don't think, relative to most of the other locations. A little flipping where Hereford seemed to do better in some other locations as well. Overall, maybe not as much in that wheat pasture, but they did really well on that winter range and fits in with some of the Hereford, low forage availability types of mantra that we've talked about for years, I think. Finishing average of the game, maybe not a lot here. Brangus did really, really well in our system. This is the only real kind of thing I'd call probably an interaction that's close to significance here. These others are fairly in line with each other across without a lot of re-ranking out of error. And finishing weight kind of similar with all of that as well. Where they finished. Obviously, this is variation. We were targeting 1350 pounds. Sorry, I should have said that in kilograms. The rest of these are metric, around 600 kilograms, something like that. With that target, this is just a variation that was still in the lot, which was pretty substantial. And so, not a lot of re-ranking, though, still, I would say. A little bit we see on carcass weight, maybe. Where there's some changes on Woodward relative to the others, maybe the other locations not as much. Markedly similar, CC some re-ranking again on Woodward, primarily on Hereford, doing a little bit better there. And fat depth, a little more across the board where I said we got some of those changes. We were seeing a little bit with Hereford and Brangus and different locations on fat depth and where the fat accumulation seems to be going. Ribeye area, these are more within error than some of the other ones, so I don't want to go deep on this. But there are a few places where Simmental seems to flip a little bit between these, as well as Hereford. But I don't think that one's within error very well. Yield grade matches the fat pretty closely, and tenderness, which is something we don't measure in our system, does seem to be affected a little bit by the environment somewhat, and we do have some places where we have some re-ranking as well. So, like I said, I don't want to go deep into these. I just want to give you a glance at what these look like right now, and we'll be trying to process these better and get a more complete picture out in a publication in the spring. We're really interested in this. I realize 120 animals a year for 3 years in each location is not a ton of power with this, but it's an initial step to try to get this done. And something that really hasn't been done for quite a long time in the industry overall or in academia. This is a stab to get that going and maybe to try to see what can we do in the future. So this was an early look at this. There's several places where breed differences seem to be robust, but there's a few incidences where I had re-ranking. So if we get out of this and we say that breed differences seem to be robust across locations, that's pretty good for our genetic evaluation system overall. So it's not necessarily a bad result. We want to be sure what our power is with that when we're talking about those results, so we can say that. But maybe these types of traits hold up pretty well. We'll be examining this with more detail soon. of course, and just overall general considerations for GP and for where all this is going right now. This is a unique resource. I think we tried to establish that yesterday. I'm trying to cement that today. And we want to have this, we're a public entity. We want this to serve our stakeholders, which is everybody in here, research, producer, breed association alike. We want to do the best job we can of that. And I think this is a resource that is getting more and more rare overall and in the industry, what the availability of this sort of thing is. Let's just remember we have a lot of potential to do good things with this and how we can supplement the research programs we all have and want to keep going forward. Both related to both projects, we need to think about the targets or genetic predictions overall. So these are two different types of programs, right? And we're looking at trying to target genetic predictions for our commercial producers, if you ask us generally. But let's take a step back and think about, is that really what we're doing and doing the best? Or are we doing the best job of targeting that we can make sure our seed stock selection continues in the direction we're going right now? How well are we doing that? And both of these questions, both of these little looks at this really address that question if that's possible. How well are we making sure our differences show up and come out in the commercial herds that are going to be using this data down the road? I think we need to take a step back and think about that. What do we want to be doing with that, and where do we want to be going in the future? And that impacts for both germ genotype by environment and for what we're doing for making sure we can predict what the performance of animals is going to be in those commercial herds, those commercial feedlots on down the road as we go. And Matt will talk a little bit about some of those sorts of things in his discussion as well. So this is just a continuation now. What are our targets? And these are things that all of us would say, if I'm going to stand with you here, right? What would you answer for what our target is from our genetic evaluation system? Number one answer, commercial cow production, right? But what are the other things we're looking at? And how do we serve all these things the best and make sure that we're getting everything out there as well as we can? And who and how are we serving all these interests? And we need to continue to emphasize what we're doing and take down that part of this is really supplement how the decisions we need to be making for where our commercial cattle system is going. And I put agenda there, that's the beginning step. Some of this we need to do that's a great beginning step, but we need to keep doing better than this for predicting what our progeny performance might be or help with managing decisions in the future. So with that, I want to acknowledge our Grand Challenge team from all these locations. It was a big effort to get this going, and people with each location. I want to acknowledge my co-authors, the GPE folks that really put a lot of heart and soul into this overall and help with making sure this program is as well run as possible. And with that, I'll go ahead and take any questions. Yeah.
Are these all purebreds?
Yes. Yeah. So everything, and that's a great question. And so the question was, are these all purebreds? And so it depends on what you mean by that. The sires that we sample for GP have been for the past almost 20 years, not quite, and then longer than that have been purebred sires, and intentionally so, where we could get them. The exception to that was Kuehn. We actually sampled Key Angus for them. But the other breeds we've been trying to make sure we're sampling purebreds. And it relates to, I kind of brought this up, but I glazed over pretty quickly. It relates to what should we be sampling in the future, given the penetrance of composites into many of these registries right now. Where should we be going for sampling those in the future to do the best job and impact differences and utilization most overall? So that's where we're thinking what we do next. And although we have a firm decision on that, but there's a good chance we need to get a lot of that in our next sampling process. In terms of the progeny, of course, they're crossbreds, right? All over the place. Yeah.
Larry, you touched on it a little bit, but dodged it a little bit, so I'm going to bring you back to it. I think it's very important the G-by-E interaction. My question is that if you find some significant results there, what are we going to do with it?
Yeah, so we know it's there. I think that's the start of this program and for why we wanted to get it going. This is not a parameterization project to say, let's take this out. I wouldn't be comfortable with that yet. But I think we need to talk about how well we're seeing those management systems in some of these places and maybe where we need to either cooperatively or research-wise do a better job of trying to get at that G-by-E. What's missing from what I talked about to do this well? Well, there's this little region called the Fescue Belt. It's not there. We don't have the Deep South with this in terms of coastal areas, and that they're probably going to be a lot different with all of this, certainly in terms of indicus composites. I don't think we're answering that question with this project on its own, but we need to be thinking as a group, where should we be targeting to do that better? And what do we need to be modeling to do that better? I think we've danced around this issue for as long as I've been a graduate student, which is a day or two ago now, and always talked about how it could be important. I think I was a graduate student at CSU, and Rick Gordon wanted to tackle this in 1998 at a session like this, I think. And big thing is data and getting the data out there to do it. I think we need to mobilize it if we're starting to see stuff and worry about it. I don't know if I have a better answer than that.
Like access, USDA database can be a little bit unknown what kind of searching things, simple recommendation of how to find.
So the quick thing is definitely contact us. So I'm sorry, thank you, Ken. Our question is, how do we get this data? The USDA database is a little untenable to find. I would agree with that. Although I still fully support the government, right? Being careful what I say here, but it is hard. And we haven't put out things as progress reports really as much as we used to. We've been doing it more in reports in places like this, yearly updates. The easy ones, the weight traits and the carpet traits are available every year, always on the Beef Improvement website, with the main place to go. And we get that usually right on the front page of that. They're always available. The harder ones are the one-off studies that we do that are feed efficiency. Kelly knows near deer, right? The heterosis project, the results of what I showed here, where that'll go eventually. And those are easier for contacting us to get directly, of course. We have a communication specialist that's going to be trying to get those out in a place where we could get those posted, maybe off the USDA website a little bit, that they can get a little bit easier to people. But it is a hard thing what the best outreach is. The people in this room, we've got extension folks that do a really good job of contacting us and get this, but they represent the extension of 3 or 4 states, right? 4 states, I think right now we're in here, that they can do that really well. If you're not in those 4 states, it's a little tough, right? How can we get those out better, and what should we be doing? Maybe we should be putting things on the extension on some of these research results sooner if we get these communication upgrades. But the short answer, the quick answer is contact us. All of our names were on this slide, and all of our emails are our first name and our last name at USDA.gov. And easy to find. And we're happy to take calls, and we're happy to take email messages anytime we can. We get a lot. but we view it as one of our most important parts of our service too. So that's our short answer, but our long answer is we're looking at ways to improve it. We need to do better yet in making sure some of this gets helped.
That end would be helpful to have a spot on the BIF website just to archive a whole bunch of that stuff and have like published final reports, but then, you know, you guys do some progress reports.
Or you just table it, right? Yeah, I think that could be very helpful. So I'm looking at Mark and Warren, but I think trying to get some of the tables even out from the research results we got might be really, really helpful to get out there. Put them in English units probably. They're recorded in metric, of course, and get those out there. You know, we show that as a regular thing, and we get visitors right now. And I think it'd be good to get out there. There's a BIF report I had last year in that session that was really going through a lot of that. We're actually ready to post a lot of those things if we wanted to do that. So that's a good idea.
So what does making data from PTE public look like?
Yeah, so that's a tough question. I think you got a hint yesterday with Mark that we're under a bit of an edict to try to make sure data is public. And I don't know the answer completely yet, Matt, because if we have all this and we just dump it in a database and say go at it, and the results are fairly disastrous, I would say, in terms of the metadata, to use the right term right now, for describing what all these things mean. And that's something we're struggling with right now. Our second, I won't say burden, our second challenge right now with what we do is we sample these with cooperation from these bulls, cooperation with industry producers and entities with the studs. And, you know, we don't necessarily have permission for all these things to go out from all those people that help us get these now. Now, we didn't buy them, but we bought them at a different price in these cases. We probably need to make sure we're following up and doing that well before we just put these things out there. All that said is we want things to be able to be public and help and figure it out. You guys know we try to make sure we're getting things to you and try to do things jointly as much as we possibly can already, but it's not an easy answer yet, and we're struggling through what we do. The easy part of that probably is the sequencing side and what we can post for references and things like that. You know, we can mask IDs and things like that, although I don't know anybody that's in, they can't figure out who the bull is if they have a sequence, but it maybe doesn't put it quite as public out there. That said, you know, we're struggling with it. We can probably do it on the sequence side. We're trying to figure out what we do on the data side and where that is in our overall system. And then there's always a bit of a few years of lag before it will be public as well, because you know, they want us to publish off it before we do the free things, and we're struggling through what the best way to do that is. Thanks, man.
The USD soy base, vegetable base, be really bad.
Yeah.
Better, because it's very hard. Spend a lot of time trying to figure out what is what there, but
Yeah, agreed. There's quite a few places. Our National Ag Library is trying to provide other solutions for this as well. I don't know where that's going to go either just yet. You know, with the sequence gen bank, we're working with project at UNL. Actually, we're not working very hard ourselves, but we're trying to help with the project at UNL with the stats group to get things into gen bank better for two reasons. The people that know how to get things into gen bank don't always take the time because they're busy doing other things, and the people that don't know how to get it in don't know how to get in. And so getting a front end for that, and maybe a way to really classify the genomic sequence is a way to get some of these things in on that side. That's not the data side, Cedric, but it's a start. All right, thank you very much. Appreciate the opportunity.